All right, guys. So we wanted to talk about earthquakes and the interior, how earthquakes help us actually identify the interior of the Earth. All right. Whenever we talk about the layers of Earth and we talk about earthquakes, primarily this stuff happens in the lithosphere. Lithosphere, there's two types of lithosphere, which is the continental and the oceanic. Obviously, the oceanic is in the ocean, continental are on the continents. And they can be as thick as about 100 kilometers thick. They're much thinner in the ocean, but generally speaking, about 100 kilometers thick. All earthquakes occur in this area, in the lithosphere. And below the lithosphere is the asthenosphere, which is really not solid. It's kind of this plasticky stuff, which is the upper mantle, essentially. Um, the area nearest the lithosphere is molten, however, and allows for the plates to move. So even though it's kind of a plastic, right there between the lithosphere and the asthenosphere is that it is like the magma that you think of. And then this can be as thick as 600 kilometers. So we got the lithosphere, which is 100 kilometers thick, and then the asthenosphere, which can be almost 600 kilometers thick. Okay, good picture of this. You can see if we look right on the crust, the brown stuff being the lithosphere, which is that sphere and solid rock. And then right below that is the asthenosphere, which is this upper mantle essentially, and then the mantle down below that. All right, so earthquakes, they must occur in a solid material for them to happen. This, of course, is a lithosphere, the rock that occurs in. It's usually a strain in the lithosphere that causes this to occur. Earthquakes do help us because it's in solid. We're able to identify the exact source of where these things happen, and where that exact occurrence is what we call the epicenter. But they can be far less than 100 kilometers thick, so they can be right towards the surface or deeper. All right, a shallow focus may occur about the mid-Atlantic ridges, generally speaking, and these are divergent boundaries, so those are boundaries that will pull apart. Deep focus are ones that happen in convergent, and those can also be deep ocean trenches, and they're the ones that push together, generally. Okay? The depth of the earthquake really has nothing to do with where they occur or how strong they are. Wave velocity increases as the denser the rock is. So we have to keep that in mind. So the more dense a rock is, the more it reacts to these earthquakes. And what they are is basically just an energy release or waves that shock through the lithosphere and cause this to occur. We have really three different types of waves, two that we'll look at primarily. We have the P wave, which is a primary wave, travels about 14 miles per second, and it can travel through almost anything, any media really, like solid rock, plastic, and the asthenosphere fluid, which would be the outer core. And the S wave, which is about 8 miles per second. They can travel through anything except fluid. And then we have the L waves, which are, or love waves, long waves. These waves can travel on the surface, and they cause the most damage. Okay, but we're going to be looking primarily at P and S waves here. The global distribution of earthquakes, follows a narrow belt. It's very consistent. One of the major hotspots would be the Pacific Belt or the Ring of Fire, an Alpine Belt in the Mediterranean, down by Greece and Italy, and then we have some around the Himalayas, and of course into Indonesia. And the mid-oceanic ridges is another system that occurs. If we take a look at it, there's of course our big Pacific plate, Indonesia, this Indonesian plate. You see all the activity with the red dots and where this happens, right across the Aleutians. There's one of our trenches. It's a little quieter. So you can see where this really does occur and drive. It's very consistent. So it's very predictable when it does the cap. Just for example, like in California, they can have hundreds of earthquakes a day. You don't always feel them all, but it's mostly because of that San Andreas fault that occurs. All right. I want you to put these terms in your journal so you can stop it here, write them down, put them in the back. We've got the seismologist, which is a person that reads seismographs. Seismographs is really a machine that records the strength of earthquakes. That's that little machine with the needle that goes back and forth. You've probably seen it on a movie or something. And then seismographs is that paper that comes out. And that's what they're actually reading, is the Earth's vibrations when this occurs between the P and the S wave. All right, each vertical line represents 1 minute. We'll see this in the next activity you'll do. And then how much time elapses from between the P and the S wave helps us identify how far away it is and where it occurs. So for this, our example is 5 minutes. If we look at this and our seismograph records the occurring of the P wave, and then here's our S wave, and if we know it took 5 minutes for the P wave to get to our machine, and then the S waves came through 5 minutes apart, that would come down to be about 2,000 meters, or 2,000 miles away. So that's how we identify it. If we take 3 different machines at least, we can triangulate that and find the epicenters to where that occurs. Okay, but you really want to notice that we're measuring the amount of time it takes a P wave versus the S wave to get to our machine and record on our seismograph. That's what we're looking at. Alright, so in this case, when the time difference is about 5 minutes, in this, the distance to the epicenter was approximately 2,000 miles. Okay, so, but remember, the greater the distance is, the longer it takes the P wave to the S wave to get there, is the longer amount of time, the farther away the earthquake occurs. And these things are all over the world where we help us record these. And the main center for that is actually in Boulder, Colorado at the USGS. That's where they bring all this data together, record that, help identify the epicenters. Alright, the next activity is going to help you really identify this and see this stuff. Go ahead and move on to that and give it a try. Talk to you later.